In this video, we're going to continue using powers of trigonometric functions, and in this case, it's going to be powers of secant and tangent. For our first example, we'll take a look at what we should do when the power of secant is even and positive. And when we have a question like that, we want to save a secant squared factor and convert everything else to tangents using a Pythagorean identity. So in our last video, when we dealt with sines and cosines, we used a Pythagorean identity that said sine squared plus cosine squared equals 1. So this is just another identity, and that's what we're going to use in this question. So what that means is I need to separate out a secant squared value. So if I have a secant squared x value, that takes care of 2 of the 4, which means I'm remaining secant squared x dx. So I basically have 2 sets of 2. One of those I'm going to save. So I'm going to save this guy to be used as essentially a derivative, because we hopefully know that when you take the derivative of tangent, you get secant squared x, and so that's why we're saving the secant squared x. The first one, we are going to use our Pythagorean identity. So instead of the first secant squared x, I have tangent squared x plus 1, and then I still have secant squared x dx. And of course, I'm just going to multiply that out. So now I have tangent squared x secant squared x plus secant squared x, all with respect to x. So essentially, I'm just going to look at each part separately. For my first part, so again, I'm just going to write this as 2 separate integrals. And if we need to, we can go ahead and do that, is to write it separately. So tan squared x secant squared x dx. And then the second is secant squared x dx. So for the first one, I'm going to do a little u sub. I'm going to say that u is equal to tangent of x, which means du is equal to secant squared x dx. So that means my first expression can be rewritten as u squared du. And my second expression, I actually can go ahead and evaluate, because what is the integral of secant squared x? It's just tangent of x plus c. So that just leaves me with the u sub and integrating u to the second power, which of course will give me u cubed over 3. And I still have tangent of x and c. And then I'm just going to replace u with tangent. So this is 1/3 tangent cubed x plus tangent of x plus c is my final solution. Now let's take a look at what happens when we have the power of the tangent is odd and positive. And in that case, we want to save a secant tangent factor and convert everything else to secants. So you might be thinking about now that I have lost my mind because I don't have any secant powers. However, I know that the tangent squared of x plus 1 is equal to the secant squared of x by a Pythagorean identity, which means I can replace a tangent squared of x, a tangent squared of x with secant squared of x minus 1. So I actually do have some secant tangent factors, I just have to create them first. So let's see how I can rewrite my initial integral as tangent squared of x so that I can use my identity. And if I took 2 out, that means, not x, x over 2, I apologize. And if I took 2 of them, that means I have 3 left. So tangent cubed x over 2 dx. So now I'm going to replace tangent squared of x over 2 with secant squared of x over 2 minus 1. So now I have the integral of secant squared of x over 2 minus 1, and I still have tangent cubed x over 2 dx. Now I'm just going to do some simplification to see what I have left. So I can take secant squared of x over 2 times tangent cubed of x over 2, and I'm going to write the tangent cubed of x over 2 first. You probably know why, because you're very intelligent. And if you don't know why, that's okay. That doesn't mean you're not intelligent. And then if I take minus 1 times tangent cubed of x over 2, I get minus, and I'm just going to make a whole new integral, minus tangent cubed x over 2 dx. Oops, don't forget your dx over here either. So here's where I am, and I've made a little bit of progress, but I still have a ways to go. What I want to do now is I want to take a look at this first integral, which I'm going to do in green, and then I'll look at the second one in blue. So if I look at my green integral, I'm sorry if you're colorblind, the first integral is u is going to be tangent of x over 2. And if u is the tangent of x over 2, then du is secant, hold on, I gotta save a little room in the front, is secant squared of x over 2 times the derivative of x over 2, which is 1/2. So that means I'm going to take my green integral, my first integral, the one I'm working with right now, and I'm going to replace tangent cubed of x over 2 with u cubed, and I'm going to replace secant squared of x over 2. And again, I need this 1/2, so I'm going to put a 1/2 on the inside, which means I need a 2 on the outside. So I have 2 times the integral of u cubed du. So I've successfully rearranged and substituted for my first or green integral. Integral, not interval. Now I'm going to look at the blue one, or the second one, tangent cubed x over 2. And if you'll notice, what I have is the same situation I had when I started. I have a bunch of tangents and not any secants. So now I have to rewrite that using that same process. So I'm going to subtract, and I'm going to just put a parenthesis there to remind me that everything after that is going to be subtracted. So tangent cubed of x over 2 can actually be written as tangent squared of x over 2 times tangent of x over 2 dx. And just like I did before, I'm just going to keep going with that green one, or the first one, until I get to the point where I can integrate everything. So this part that I have written in blue, I am going to replace tangent squared with secant squared instead, minus 1. So now I have minus, again, parentheses, so everything to the right is going to be subtracted. So tangent squared x over 2 is now secant squared x over 2 minus 1, and then still times tangent x over 2 dx. So hopefully you see where I'm going with this, because it's really kind of just a repeat of exactly what I did before. So now I still have my 2 times the integral of u cubed du, and all of the stuff in blue is now minus the parentheses, and then secant squared of x over 2, tangent of x over 2. I again am going to write the tangent first for the exact same reason, because that's going to be u, whereas the secant squared is going to be du. And then I'm subtracting 1 times tangent of x over 2. So that's just the integral of tangent of x over 2 dx. Now, before I continue, I want to address this negative. I have a negative and it's in front of everything that I've written in blue, or everything to the right of that negative, which means that I can change it into a plus. This guy is going to be minus, but this guy was a minus and then a minus, so that one's actually going to be plus. So it's important that you keep those signs straight. Now let's continue. Again, I'm just going to keep writing that first integral until I'm ready to integrate everything, and I'm not there yet. So my first integral is 2 times the integral of u cubed du. And the second, which I'm going to make yellow, is going to then be minus, because obviously I have that negative there. And then I'm actually going to use the same u and du I did before. So just as I did before, I have tangent of x over 2, which is going to be u, and then I have 1/2 times the secant of x over 2. So I need a 1/2 on the inside, which means I need a 2 on the outside. So this is minus 2 times the integral of u, just u to the first because it's tangent to the first, du. And then I have no color, blue. I've got plus tangent of x, or the integral of tangent of x over 2 du. Now, there's no u substitution needed for that last guy. If you don't know all of your basic integration formulas, Google to find a great sheet of all of your integration formulas, because if I take the integral of tangent of x over 2, I should get the natural log of the cosine, or the absolute value of the cosine of x over 2 plus c. And then again, because it's divided by 2 here, I'm going to have a 2 out front. So this is a plus 2 times the natural log of the absolute value of cosine of x over 2 plus c. I think I messed up a sign. Hold on. Oh, sorry. This is actually negative. And the negative, again, comes from the identity of taking the integral of the tangent of x over 2. So the integral of tangent of x is negative natural log cosine of x. So that's where the negative comes in. All right, so now I've already integrated the one at the end in blue. And what I have left is everything else. So I have 2 times u cubed du is u to the 4th over 4. And then I have minus 2. And then I have u to the 1st, which gives me u squared over 2. And then I already kind of cheated and integrated that last guy. That was 2 times the natural log of cosine x over 2 plus c. And now I just have to do my u substitution. So I have 2 and 4 turns into 1 and 2, so I have 1/2. And then u to the 4th would be tangent to the 4th of x over 2. I have minus 2 and 2, and those cancel out. And so I have u squared, which would be tangent squared of x over 2. And then I have minus 2 times the natural log of the absolute value of cosine of x over 2 plus c. And that is my final answer. Hooray and hooray. There's actually one example we're going to skip, and that is what happens when we have only tangent powers and they are even. And the reason we're skipping it, it's because you would solve it exactly as we did our last example, where you replace tangent to the second power with secant squared x minus 1 and continue to solve from there. So we're not going to spend time on that, just so that this isn't a crazy long video. I think it kind of is a crazy long video already, but we'll just go with it. Hey, let's just do it. So this one is the power of secant is odd and positive with no tangent factor. We have to use integration by parts. So hopefully you've watched that video and you're comfortable with that method. If not, go back and watch that video right quick. I've copied this formula for us, and we're going to be thinking about secant cubed pi x as broken into a product of secant squared pi x and secant pi x dx. And so again, we have choices to make. We have u, and then we have to find du, and then we have v that we have to find from what we choose for dv. So these are the two choices, u and dv. So I can either choose secant squared pi x or secant pi x to be u and the other one to be dv. I'm going to choose dv to be secant squared pi x. And the reason that I'm doing that is because I know that the derivative of tangent is secant squared, and that means v is pretty easy to figure out. It's going to be tangent of pi x, and then of course because of this pi, it's going to be 1 over pi. Now if I use secant squared pi x to be dv, then secant of pi x is going to be u, and then the derivative of u is, sorry, not secant. Oh, please erase. The derivative of u is going to be secant pi x tangent pi x, and then again this one would be times pi using the chain rule. So now that I have all of that, let's go ahead and write what I have done so far, and this one again is going to be kind of a lot of work. So I have that the integral of secant cubed pi x dx is equal to u times v, so secant pi x times 1 over pi tangent pi x minus the integral of v, which is 1 over pi, I'm going to put the 1 over pi on the outside, tan pi x times du, which is pi secant pi x tangent pi x. Again, let's just simplify what we can. So I'm going to keep my secant cubed pi x dx on the left side. On the right side, there's not much I can do here except for just write it as 1 over pi secant pi x tangent pi x. And then you'll notice here I have a 1 over pi, and then I also have a factor of pi, so those essentially will cancel each other out. And I'll end up with minus, and then I have the integral of tangent pi x times secant pi x tangent pi x. So what I really have is tangent squared pi x secant pi x. Just as I did on my last example, I'm going to replace tangent pi x, and so I have secant cubed pi x dx is equal to 1 over pi secant pi x tangent pi x, and then I have minus the integral, and tangent squared pi x is going to be replaced with secant squared pi x minus 1, and then I still have secant pi x. Now I'm going to distribute on the right hand side, so everything else is going to remain the same, which just means a lot of copying. I'll try to do it as quickly as I can so you're not just sitting there watching me copy my work over and over and over and over again. So now I have the integral of secant cubed pi x, and then I'm actually going to, when I take 1 times secant pi x, I get obviously just secant pi x. And what I want to do is, instead of having these parentheses here, I'm just going to distribute that negative. So this negative here is going to make this first one negative, but this guy, which would have been a negative and then a negative, this is actually going to be a plus. Now, this part's a little bit tricky. It's not something that you're going to do very often, but obviously this question is kind of getting away from us. There's a lot going on. So what I'm going to do is, if you'll notice, we have an integral of secant cubed pi x dx and an integral of secant cubed pi x dx as well. I think I've forgotten to write a lot of dx's, but you get the idea. So what I'm going to do is I'm just going to add this expression to each side, because if I add it to the right side, it's going to go away. And if I add it to the left side, I just have two of them. It's just like algebra. X plus x is 2x. So I have 2 times the integral of secant cubed pi x dx is equal to, and then I have left over 1 over pi secant pi x tangent pi x. And then I have the integral of secant pi x dx. And the integral of secant pi x dx is going to be, so it's plus, and it's going to be 1 over pi, and it's the natural log, and again, this is just from your integral table, if you don't know the rule off the top of your head, like I don't, for the integral of secant. The integral of secant is the natural log of secant, and then plus tangent pi x, and then plus c. So we're getting real close now. The only thing now we need to take care of is the fact that each of the things on the right side, each of my values, has 1 over pi in front, so I can actually bring that 1 over pi out. But if you'll notice, I'm trying to solve for one of these, and this expression accounts for 2 of these. So what I'm going to do is I'm going to divide each side by 2, which means not only am I going to take the factor of 1 over pi out of everything, I'm going to divide by 2. So I actually have 1 over 2 pi times everything that I have left, which is secant pi x tangent pi x, and then plus the natural log of the secant of pi x plus the tangent of pi x, absolute value, and then plus c. And that is your final answer. So we've talked about 4 strategies for dealing with secant tangent. Now we want to look at when none of those strategies work, we have to convert to sine and cosine. So we have to use the fact that secant of x is equivalent to 1 over cosine of x, and the fact that tangent of x is equivalent to sine of x over cosine of x. And essentially just rewrite my integral. So my integral as it stands is the secant of x multiplied by tangent of x to the negative second power, dx. And so I'm going to replace secant with 1 over cosine, and I'm going to replace tangent with sine over cosine, and then to the negative second dx. Now, we hopefully know that when you have a negative exponent, that's just telling you to take the reciprocal. So this is actually the integral of 1 over cosine of x, and then this is cosine of x over sine of x squared, or if I distribute the squared, it's cosine squared of x over sine squared of x dx. From here, I can reduce. So I have cosine of x here. I can reduce it with one of those. So my new integral is that I have sine to the negative second of x, cosine of x dx. And again, I wrote it in that order because I'm going to let u equal sine of x, which means du, the derivative of sine of x, is cosine of x dx. So I can rewrite sine to the negative second of x as u to the negative 2, and cosine of x dx as du. Which means when I integrate, I get u to the negative 1 over negative 1 plus c. Now u to the negative 1 is sine to the negative 1 x over negative 1 plus c, which is really just, not as a fraction, would be negative sine and then plus c. Now, keeping in mind that this negative 1 just makes it a fraction, tells me this is actually negative 1 over sine of x plus c. And of course, 1 over sine of x can be rewritten as cosecant of x plus c. And so this is going to be my final simplified answer. If you stuck with me through that whole video, well done. You deserve to go have a snack now because that was a doozy. Coming up next, we're going to take a look at trigonometric substitution.